Hi everyone, in this video just going to go through all of the basic things you need to know about binary numbers when working with them in a computer. Okay, and in this video we're just going to say obviously what binary actually is, then converting binary into something called a denary number, which is just our normal numbers that we use every day, and then converting those numbers which are normal back into binary so we can understand them in part of a computer. So the question you might be asking yourself is what actually is binary? Now binary is quite simply just zeros and ones. Now those zeros and ones actually mean something inside the computer, obviously, because computers, or we as people don't actually think of numbers as zeros and ones, obviously. We count from 0 to 9, whereas binary is obviously just 0 or 1, it's only one or the other. And that's because they control little switches inside of our computer. Obviously with 0 being off and 1 being on. So with this, inside the computer, there are millions of switches, and those millions of switches make decisions as to what actually happens inside of a computer for whatever reason or what task it might be doing. But the main thing is working out how you convert a binary number into denary. Now, you might be presented with a binary number, quite a simple binary number, which is just 0101. But if you had no idea what that actually meant, you'd be, well, is that number 101? Is it 2? There's no context as to what this number might actually mean. So what we actually have to do is we have to put a table together. Now this table is always the same. You always use the same table always inside of binary numbers. And it always starts with a 1 at the far right hand side. And all of the other numbers double. So you should have 1, 2, 4, 8. For this number we're only using the 4 numbers. But when you use other numbers you might have 16, 32, 64 and 128. So starting from the right hand side, you would fill in the columns. So you'd have 1, 0, 1, 0 there. So that number falls into that column. And the rest would just be zeros. Now the reason we use 8 numbers like this is because that is what we call a byte. One individual bit is just a one binary digit. But when you have 4 of them, that makes something called a nibble. And 8 of them makes something called a byte. And you might have heard of bytes, because a byte is like a megabyte, a kilobyte, or a gigabyte. This is actually storage inside of our computer. So now that you can see we put it in the table, what we know is we have one lot of 4, no lots of 2, and one lot of 1. So quite simply, we just say, well, we've got 4, and we add that to 1. So now we know that 0101 must be 5. So if we converted this binary number into denary, 0101 is clearly 5. So if you'd like to pause the video at this point, just to see how it go yourself, all right, and then unpause it and we'll go through the answers after. Okay, so obviously here, there are a few tips and tricks to make this a little easier for you, but the first few numbers are fairly straightforward. We've only got 116 here, one lot of 2 and one lot of 1. So simply that would just be 16 plus 2 plus 1, which would be 19. Now we've got a lot of different ones here, and if you try to add them all in one straight line, these are only small numbers, but there's a little trick you can do, because you'll notice that 16 and 4, when added together, make 20, which is quite a nice round number. You'll also find that 8 and 2, when added together, makes 10. And then you've got the 1 on the far side. So therefore, 20 plus 10 plus 1 is very easy to do. That's obviously 31. So that one's fairly manageable. And you can use the same method for different numbers too. So you'll notice that 64 and 16 go quite nicely together, making 80. And you'll find that 8 and 2 again makes that 10. Nice and easy to work those ones out. So therefore, that one will be 90. Now, at the bottom here, you'll notice that we've got almost all of them are 1s, except from only a couple where we've just got some zeros here. Now, a number worth knowing is that all of the numbers added together is 255. Now, the reason we know this is because 255 is 1 less than this 128 at the top. So if we have all of these numbers, it would be 1 less than this number doubled, which would be, of course, 256. So because it's 1 less than that, we know that all of these numbers added together would be 255, but we don't have all of these numbers because we're missing 8 and 2. So what we have to say is 255 minus 10, because 8 and 2 make 10, and therefore our answer must be 245. You could add them all up and you would eventually get there in the end. Obviously that's 192 plus 32, which is 224. You'd eventually get there, but you may as well make your life a little easier. If you know that all of these numbers added together is 255, it does make life a little bit easier. And now we can convert from going the other way. So denary numbers, in case it wasn't clear from earlier, denary are just our normal numbers. So when we were writing these a second ago, if we can get it back, these numbers here, these are our denary numbers that we use in every day. And obviously binary numbers are what we're trying to work toward. So if we're converting from the other way, let's say we've got a number like, 25. We have to use the table again. It's exactly the same table as I mentioned earlier. So always start from the right-hand side and always double. Okay, now the way we work this out is we see, is 25 greater than or less than 128? Now, 25 is obviously much smaller than 128, so 128 will not go into 25, so we have to put a 0 there. And 64 is still too big as well, and so is 32. But 16 is smaller than 25, so we have to put a 1 in here, and then say, well, 25 minus 16, well, that's going to be 9. And we now check to see if 9 is greater than or less than 8. And of course, 9 is bigger than 8. So we need to put a 1 in here and take 8 away from 9, which gives us 1 remaining. Now 4 is still too big, so we need to put a 0 there. 4 in comparison to 1, that is. 2 is big, but 1 is fine. So you should see, and we can add this up again by going through, and 16 and 8 is definitely 24, plus 1, which makes 25. There's no other combination of these numbers that will get to 25, only the ones that we've set out just here. Again, if you want to have a go at the task, on here, and then we'll go through the answers shortly. If you want to pause the video, now. And by some coincidence, we seem to have the first answer is actually 25. And you can see that 0, 0, 0, 1, because 16 is the smallest of these. It's not too big, of course. Then plus 8 would get you to 24. And then plus 1 gets you 25. Now 58, again, 128 is too big. 64 is too big. And 32 is fine. And here, if you did 58 minus 32, you would have 26. So 26 means that we need 16, and we need to make 10 more, because 26 minus 16 is obviously 10. And then you can easily make 10 by adding 8 and 2 together. 139, again, we just use our 128. And if we take 139 away, or 128 away from 139 even, that would give us 11 left over. So we need to make 11, and that's nice and straightforward. We use our 10 from earlier, and then add 1. Now 242, again, the easiest way of doing this is to say, well, I know that all of these numbers added together, all of the ones here, would be 255. But I don't want 255, I want to take away 255, and I want to take 242 away from that, which leaves me with 13. So I've got to take 13 away. Now I know that 8, 4, and 1 make 13. So I can say, okay, well, I need every single one of these numbers except for 8, 4, and 1. And there we have it. I have 242. Now, just before we finish up, there's a couple of top tips you want to be aware of. You'll notice that the numbers which have a 1 on the right-hand side in the 1 column, this definitely means that these are odd numbers. So you can do a quick check and say, well, that's got a 1 on the end, therefore this must be an odd number, which is absolutely true. You can see the odd numbers have a 1 on the end, and the even numbers all have a 0. And the good top tip to go for is if we notice again that we have, let's say, let's use a pink pen, we have a 1 and 1 here. That means that 2 and 1 would make 3, and 3 is 1 less than 4. If I had 4, 2, and 1, that's 7, which is 1 less than 8. So you can kind of use this to work out things very quickly. So if I know very quickly that I have all of these numbers, that's 1 less than 32, so that one must be 31. If I have 1 here, that one must be 63, because that's 1 less than 64. So little tips and tricks like that do make life a little easier to add these up. But using that and grouping, when I say like, oh, 64 and 16 is 80, that's a nice quick way of working that out. Using those is a really fast way to get through binary. And binary is not difficult. Everybody can do binary. It's just a case of how quickly you get used to doing it. So thank you for watching. If you have any further comments, just leave some comments down below, and I'll see if I can help you out. But thank you for watching.